Hey everyone, let's go ahead and watch Mr. Vogt do a oxidation reduction half reaction balancing problem. This is where we left off in class, and I said that I was gonna do this one for you. So let's go ahead and let's do it. So let me pull this up. And off we go. So here is our skeleton equation, and we want to go ahead and we want to balance this. So first thing that we're going to have to do is figure out who is being oxidized and who's being reduced. Okay, now in this case, I'm going to find that manganese is a +7, and it converts into a +2. So therefore, manganese is being reduced. Okay, in this case, carbon here, let's see, -2, -4, -2. So this is going to be a +2 for the carbon. And over here, it's going to have to be a +4. Okay, and that's oxidation. Okay, the number went up and the number went down. So life is good. Okay, let's go ahead and write our reduction half reaction first. So we're going to take MnO4 minus, then I'm going to leave myself some space because I know that I have to add some electrons and some other things. Now this is going to convert into Mn2+. So we're going to go ahead and just deal with this equation all by itself to start with. We see that the manganese are balanced, so that's good. Now we have to balance 4 oxygens. So we're going to balance that with 4 moles of H2O, which provides 4 oxygen atoms, but it provides 8 hydrogens. So on this side, we're going to balance with 8 H+. Now we're going to save the electrons for last. Okay, so don't try and muscle your way through it. Work through the problem step by step according to the Google slide direction sheet. So here we've got 8 positive charges and we have 1 mole of negative. So we have +8 minus 1, that's a total of a +7 on this side. And over here, this is like an imaginary 0, and then we've got a 2, so we're at a +2. So we have went from a +7 to a +2, which means we have gained 5 electrons. Bam, just like that. Now let's go ahead and let's do the top equation. We're going to do the same thing to this problem. So CO2, all right, balance the carbon, done. Balance the oxygen, done. So we don't have to add water to this one, but we do have to add hydrogen ions to this side. So 2 hydrogens, so we add 2 hydrogens. And now we see that we have a 0 on this side, okay, and on this side we have a 0 and 2 positives. So we're going to have to add 2 electrons to this side. Okay, so I left this big space, but I really didn't need it. That's okay. Okay, so now each half reaction is balanced by mass and by charge. So next what we're going to do is we're going to make sure that the transfer of electrons between each equation is balanced. So I'm going to have to multiply this by 5 to get to 10, that's the lowest common denominator. Multiply this by 2 so that I can get to 10, and then I'm going to go ahead and I'm going to write everything out. Just collect all the terms. So I've got 5 of those, and then down here I have 2 MnO4 minus plus 16 hydrogens, yippee, plus 10 electrons. Uh-oh, gonna run out of space here maybe. Yikes, this is gonna be a close one. All right, so let's go over here. So we've got 5 CO2s, and we've got 10 hydrogens, and 10 electrons. Oh boy, and then we gotta come down here, and we also have 2Mn plus 2, and we've got 8 H2O. All right, so what can we cross out? We're going to cross out some hydrogens. So you see how we've got hydrogen on this side and a hydrogen on that side. So we can take 10 hydrogens from each side, and that's going to leave us with 6 on that side, and we can cross out the electrons. So now let's go ahead and rewrite our final balanced net ionic equation. And I'm going to try and manage my paper a little bit better. Okay, so we still have 6 hydrogens, excuse me, 5 CO2s, Ooh, good, some things canceled out. Awesome. And 8 H2Os. Yep, there it is. So that's our final. Now from here, what we can do is we can actually do something useful, like solve a problem, do some stoichiometry, etc., etc. If you follow what I'm asking you to do for tomorrow's lesson, once you've done this, you should be watching a redox titration video, which is going to be the practical application of this fun stuff. Super duper. Thanks for watching. We'll see you later.